Good morning, everyone. Welcome to Virtual Breakfast. My name is Phil Cates. I'm an extension educator based now in Huron County. I moved from Lapeer County to Huron County, and we're excited for my favorite topic, which is forages today. I'm really privileged to have Dr. Kim Cassida with us this morning to talk about forages. Kim is our associate professor for forages and cover crops. She has been a big part of my programming efforts through the years, and so I'm glad to have Kim here. And so, Kim, I'm going to stop sharing and I'm going to ask you to take it away. Welcome.
Good morning, everyone. We're also going to talk about one of my favorite topics, forages. I'm glad to be here again with you. And our topic for today stems from a lot of questions I've been getting recently, which are about forage quality. So Phil and I and many others for many years now have been telling all of you forage producers that testing your forage quality is very important because you can use it as a marketing tool. Um, and I think that a lot of you are starting to do that. But the questions that I'm getting now is that, well, I tested it and I got the results back, but I don't know how to interpret this in a way that I can use on my farm. So that is the goal of my talk today, is to give you a little bit of information about how to use the information that you get from a test. So the first question here is, what exactly is forage quality? We talk about this a lot, but what does it mean? So forage quality in the jargon of feeding animals is the potential of the forage to produce a desired response in an animal. We're always thinking about the fact that this feed is going to be fed to something, and therefore it is going to you're going to have certain goals as to what you want to get out of that. Now, that is a different thing than forage nutritive value. Forage nutritive value is basically what you get back on your forage test. And this is going to be specific quantification of nutrient concentrations. It may talk about digestibility of different components and constituents. It may talk about the end products of digestion. And we use those numbers to try and give us a prediction of how the animal will respond to it. But the numbers themselves don't necessarily tell us what the animal is going to do. Now, the title of this talk is to optimize forage quality. And optimize means to make the best use of something. So that relates to everything because you have to keep in mind that the nutrient concentration, all right, and availability of nutrients that is appropriate for your intended purpose is going to be different depending on what your intended purpose is. And for this, animal species is important. We don't have the same parameters for every type of animal as to what high quality would be. And even within a species of animals, so you say it's a cow, all right? All cows are not the same. It's going to, the quality of the feed that you need to provide for them is going to be different depending on the stage of production they're in. And we can generally say that if the animal is simply at maintenance, in other words, they're just hanging out, existing, not really doing anything, that's going to have the lowest need for nutrients. If the animal is working in any way, so that might, for example, be a horse that's being ridden, or it could even be a cow. If the animal is walking around a lot, that's going to use more energy than an animal that's just standing around and not having to go very far. Pregnancy is our next level of need, with growth above that, and then finally lactation being the highest needs for nutrients. Now, obviously, in some cases, animals may be in more than one of these classes at the same time. For example, they could be a growing heifer that is pregnant and also lactating. So this, you have to look at what this endpoint is going to be. Another very important factor in quality that I always mention to people is that it needs to be palatable. And that means that the animals need to be willing to eat it. You can force animals to eat things they don't really want to if they're hungry enough, but that is a struggle. And this is an error that's been made many, many times over the decades when some new forage came on the scene and it grew really, really well. And it might have a lot of really good features, but then when we went to actually feed it to animals, we discovered they really didn't like it. Um, and that is not a good thing. Another factor in forage quality that really is that it needs to be free of anti-quality factors that are originating from that forage plant. So this might include inherent toxins like nitrate toxicity in the forage material, any toxins that are created by that plant, dust that is created during the preservation process. An example of that would be the hairs on red clover that cause that hay to be dusty. And lastly, we want it to be free of outside contaminants that didn't come from the plant. And this could be things like mold, soil contamination from the field, Clostridia, and other types of bacteria, weeds, manure, trash, meaning, if you have a hay field that's close to the road, I'm sure you've picked up trash in it from things people threw out on the roadway, sticks, dead animals that were picked up during the harvest process. We don't want those things in there either. Now, so you've done your forage test, you've got some results back, you've got a sea of numbers in front of you, and you as a forage producer, all right, now you have to interpret these numbers in a way that you can communicate to your client how good this hay is. Now, for the purpose of this talk here, other than pointing out the importance of animals, this is not going to be a talk about ration balancing. So if you have a forage, you're going to be working with your nutritionist to balance what is in that feed, and they will use all those other things that are on the test report, all the fine print and a lot of the detailed measurements to help balance the ration and supplement it in a way that's going to meet the needs of your specific animals. But if you're looking at it from the viewpoint of, I want to sell this product or market it, what are you going to be looking at? Crude protein is an important number. And this is going to give you an estimated amount of protein that is in that feed. Another important component are the cell wall components, and there are three of these that are something that you can directly use when you're marketing. Um, There are many others that I'm not going to talk about that might be used in ration balancing, but the big three are neutral detergent fiber, abbreviated as NDF, sometimes with other letters attached to the front or the back of that. But if you see that NDF anywhere in the name of the constituent, that's talking about this one. And then there's acid detergent fiber, or ADF, and lignin. Now, you might think that these detergent fiber names are a little strange. They are referring to the cell wall of the plant. The names come from the actual lab method that's used to determine them. We boil the fiber in detergent, hence the names. That has nothing to do with the nutritional value of it. And I'm going to talk here in a minute about some benchmarks for some of these. Another big constituent is sugar. There are two measurements that look at that. Water soluble carbohydrate, WSC, which is all the sugar. And then there's a subdivision of that, ethanol soluble carbohydrates, ESC, which is just the fructans, which is a special type of plant sugar. You will have a measurement for ash, and this measures the minerals that are in the soil. There will be a measurement for something called total digestible nutrients. This is a calculated measurement, and it can be done several different ways. So your test may show you several different numbers for this. But this is basically trying to give you an overview of the total nutritional value of the nutrients in that feed. And lastly, we have some very important numbers called index values that are used when we are pricing hay on the market. And these are called relative feed quality and relative forage quality, or sorry, relative feed value. I didn't even put that in there right. And relative forage quality. So what are these? Their primary use for these two things, they are calculated numbers and they have nothing whatsoever to do with ration balancing. Your nutritionist is not going to use them when they formulate supplements. These are primarily used as a tool for marketing and pricing hay on the market. And in the construction of the indexes, a value of 100 is defined as full bloom alfalfa at 53% NDF and 41% ADF. That is not very good quality hay. That's I guess originally it was considered to be average, but it's really not very good on our standards of today. So that has no units, and that would be a 100. So anything that has an index that is less than 100 is not as good as that full bloom alfalfa. Okay, it's worse hay. And if the index is greater than 100, then it's better hay. So this is the word relative here means that it's relative to another lot of hay. So the bigger the number is here, the better the hay is. We have two different measurements here. Relative feed value is the older one. This calculation is based only on the ADF and NDF in the forage. It's fairly limited. Um, we have a newer calculation in the RFQ, and this one includes all of the big components of the feed that contribute to forage quality. So, or that would be NDF, ADF, protein, fats, and most importantly, it includes an estimate of the fiber digestibility. And this is a huge factor because one thing that we learned fairly early on is that RFV didn't predict the feeding value of grasses very well. And we discovered the reason for this is that the fiber digestibility in grass is a lot greater than in alfalfa. The original RFV equation was developed mostly for alfalfa. So when we try to use RFV on grasses, that is going to underestimate the quality of that grass or grass alfalfa mixtures. And I can demonstrate this looking at the data chart here. This is forage quality data that we've collected from an experiment looking at alfalfa grass mixtures that I've been working on here for about 4 years. And if you look at the purple dots, this is the relationship between the RFV value and the RFQ value for all of our alfalfa samples that we collected on that experiment. And the black line shows the average of those. The green line or the green dots, this is pure grass. So one thing that I want you to look at here is, oops, why are we not advancing? There we go. So if you look at the value of the RFE and the RFQ for an alfalfa sample, so I just picked a point here on the left and I carried it over to the average line. All right. And then I follow that down to the RFQ number. It's pretty darn close to the same number for both axes, okay, for the alfalfa. Now, if you look at this for grass, we start here at an RFE of about 110%, or 110, sorry, it's not a percent. And then follow that down. The RFQ value of a grass sample is really about 150. So the relative quality of that grass is much, much higher in the RFQ scale. And because that's taking account of that better digestibility. Now, this is important because when we look at pricing hay on the market, typically we are going to see a premium of about $2 per ton in the price of the hay for every extra point of RFV or RFQ that you have in that forage test. All right. So if you were valuing your grass hay on the RFV value, it would feed out more similar to the number shown for RFQ, but you would be not charging enough for it. Also in this experiment, just for fun, I put in another version of the chart here where we mixed in all of our alfalfa grass mix samples. So you see they tend to fall somewhere between the alfalfa and the grass. And that is because of the variable amount of alfalfa versus grass that might be in them. All right. So basically, our take-home message here is that if you are selling pure alfalfa, it doesn't really matter which index you use. You can use either one. But if you are selling grass or a grass legume mixture, you should be using the RFQ standard to price your hay. All right. Here are those benchmarks I promised for how to define optimal quality for different types of animals. There's a lot of versions of this slide going around on the internet, and I played with it a little bit last night to modernize it. All right. So we're looking at RFV across the bottom, ranging from that 100 average hay up to 200, which is a pretty good quality hay, but certainly possible here in Michigan. And you can see, as I pointed out earlier, the lactating animals are going to be at the top end of the scale, followed by the growing animals, um, are lower, not, I shouldn't say lower performance, like a beef cow, a ewe, a doe, or a horse that's lactating is not lactating to the same level as a dairy cow. So they're more in the middle of this range. And then our dry animals or animals that are not doing much of anything are down here at the bottom. We can use 150 benchmark as RFV as quote unquote good quality hay that will meet the needs of almost any animals except for these early lactation dairy and these growing animals. For those, we like to see a number closer to 170. Okay. And more is good. So if you're looking at benchmarks for dairy quality forage, I'm taking these from low to high. We can use a number of less than 10% ash. That's the mineral. So I'm going to talk about that a bit in a minute. At least 20% crude protein, less than 30% ADF, less than 40% NDF, at least 60% on any of your TDN calculations, and at least 170% RFU. RFV. Okay. Now, for other lactating or growing livestock, we would like to see at least 16% crude protein and at least the 150% RFV. And there's one specialty note that I'll make for horses, because if you're selling hay on the horse market, you're going to get these requests. Some horses have an intolerance of sugar in their diet. These are usually referred to as metabolic horses. And you may have clients that are asking you for hay that contains less than 10% water-soluble carbohydrate. And that's where that comes from, because those horses can't tolerate more sugar than that in the diet. So there is a premium market for that. Now, I'm going to talk here now about ways that we can help optimize the yield versus the quality. This chart is showing the relationship between yield and quality. This is a classic dilemma because in forages, as yield goes up, quality always goes down. The green line here shows the yield curve of the feed. While the blue is showing the increase in cell wall that goes along with that increase in size. Cell wall is not where the action is. Cell wall contains a lot of lignin. That's going to make your quality go down, because it is substituting for protein, non-fiber carbohydrates, leaf digestibility, reduces the intake by the animal, and it reduces mineral. All right. So as the plant is progressing through its maturity stages, your quality is going to tank. That's just the way it is. So harvesting at a younger stage of maturity is always the single most easy way to improve your forage quality. Again, why is the immature forage more nutritious? If you look at a plant cell that's immature, the cell wall is small and undeveloped. We have a big chamber for cell contents where the protein, sugars, and starch are. But as that plant cell gets older, the cell wall gets thicker, both the inner and outer cell wall. There's more lignin in that because it's helping to hold the plant up. And all of that is making it less digestible. And also that immature forage has more leaves in it relative to stem. And stem is not as digestible as leaves. So I pulled some data from a database in Wisconsin where they have posted scissor clip numbers for first cut alfalfa. I just pulled some typical farms out of that. In a scissors clip system, the farmers are just going out twice a week on the field, clipping a sample, sending it to the lab, and getting the actual numbers back. This helps them determine when to harvest. So on these 4 different farms, we're pulled from 4 different years and 4 different places in Wisconsin. So there's going to be some variability depending on weather here. But what you can see is in all these cases, the relative forage value or relative feed value is declining pretty impressively with time. And if you do a regression on this, what you find is across these data sets, the RFV is decreasing from 2.7 to 7.5 points per day that you wait on harvest. All right. So if you're valuing that RFV at $2 per ton for every point, a 7.5 point loss is $15 per ton of lost value that you could price that hay at in a day. And if you start waiting a few days or a week, you can see where that adds up pretty fast. So one tip for trying to maintain this is to actually, if you have a large acreage, start cutting a little bit before the alfalfa is actually at the late bud stage that you're targeting. Because if you have a lot of acreage to do and it's going to take you a couple of days and you don't start until it's ready, then it's going to be way past where you want it to be by the time you're finished. Keep in mind that forage quality is never better than it is at the very moment that the forage is cut. You're only going to go downhill from there during the harvest process due to losses due to plant respiration, shatter of leaves, contamination with soil, might rain on it. It could be bleached by the sun, or you could fail to get it dried or ensiled properly. And I talked about a lot of these things in virtual breakfast last year. Don't have time today to go over all of it. But I do want to say a few things regarding the importance of getting your hay and haylage off the field as quickly as possible in order to maintain good quality. Phase 1 photosynthetic drying happens when the plant has just been cut. It's still actively photosynthesizing, and this means it's pumping water out through its leaf stomata. And this gives you an opportunity to dry that down really fast, down to about 70% moisture. And the plant is still burning sugars while it's doing this. So this is why you want this to happen fast. And it requires sunlight falling on the plant to work. The second phase of drying is evaporation. It's much slower. It will take the material down to 30% moisture. Importantly, when we hit the 60% moisture point, respiration is going to stop. All right. And that means you're no longer burning sugars in those plants and it's more stable. This phase is highly influenced by using a conditioner on your mower and how you set up your windrows. And lastly, we have phase 3 evaporative drying, which is the loss of the last little bit of water down to hay moisture level, and it is the slowest. So this is one of the advantages for making haylage over hay is that you can get it off the field during phase 2 drying. You don't even need the phase 3 because you don't need to get it down to that moisture. And that means less opportunity for it to be rained on and for other things to go wrong. The most important thing that influences the speed of that early drying has been shown to be the width of the swath. A lot of our older hay mowers were built on a previous assumption that narrow swaths or windrows were good. We now know that a wide swath is much better because it will speed up that phase 1 drying because you're exposing a lot of the material to the sun to drive that photosynthetic drying. So our current recommendations are that our swath width should be at least 60 to 70% of our mower width or even more if you can do that. You also should get that stubble up off the ground or get the swath up off the ground on at least a 3-inch stubble. And this gives you the ability to get it dry faster, showing here in the chart the difference between a wide swath in the blue and a narrow swath in the orange is that you're going to get to 60% moisture about 4 hours earlier on the wide swath than you are on the narrower. And if you're taking it down to hay moisture, that is going to happen almost a full day earlier than if you are starting with that narrow swath.
Kim, I'm going to ask you to hold off on the ash because
Okay.
we're running really late today. So
Okay.
I've got some questions that have come in. And Kim, when you were talking about your RFV and RFQ work that has been done, you had the lines up there showing the relative feed value and the relative feed quality for your research. What grasses were you looking at? And I'm going to add to William's question, does species of grass change that relative feed quality?
For the grasses that you're normally going to be seeing us use here in Michigan, which are all cool season perennial grasses, you would not really expect to see a difference between the grasses themselves. What you might see is a difference in the timing of when particular grasses head out and crater their quality. But what we were trying to do in that study was match the grasses up to be compatible with harvesting alfalfa. The three that we were using were a late orchard grass, meadow fescue, and tall fescue. But I wouldn't necessarily expect the relationship to look different if you had Timothy or other things either, or smooth brome. They're all going to
All right,
behave about the same.
good. Thank you. So what the next question from Bill is, what is the daily gain in dry matter of alfalfa when you go between 200 to 150 relative feed value or RFQ?
That's a really good question. I don't have a number right here in front of me, but typically it would, and I assume when you say dry matter, you're talking about the dry matter yield, and not the
Yes.
moisture content. Uh, you're probably going to be seeing about 100 pounds per acre, at least growing at that time of year, um, per day, maybe more at peak. So you're getting a significant bump in yield by waiting. So that's where you have to think about if you can get the premium for the quality. So if in the market that you're selling to, they don't really care about quality of the feed, um, you may be more, as a grower, you may be more interested in getting the tonnage. But if you can get a premium for the quality, certainly if you're selling into the dairy market, that's when it really becomes important to know what that quality looks like. And certainly if you're feeding the forage to your own animals, you're going to be much more concerned about the quality, than you are if perhaps if you're selling it.
All right, thank you. Steve, I'm sorry, Jeff, I'm going to ask you to put up your slides again and show that CCA QR code. We had someone that got kicked out of Zoom and has a mind of its own many times. And so if you could do that for us, I would appreciate it.
Just a
And
moment here.
sure. And while you're looking at that, I've got another question for Kim. Many times I see RFQ, I see RFV on different labs that are expressing that for their forages. Is there a way to go from one to the other, depending on which one you receive in your lab results?
Not really. I mean, I think almost any commercial forage lab that's been certified by the National Forage Testing Association is going to be reporting both of those. I'd be hard to think of a reason why they wouldn't include both.
Okay.
So again, it just gets down to the fact that if it is a pure alfalfa, it really doesn't matter which one you use. But if you've got any grass in that at all, you should use the RFQ, is going to give you a much more accurate assessment of the quality of that material.
All right, good. I had a question from a producer, and I'm not sure if they're on this morning, Jeff, but the question was, how accurate are the radar assessments of fallen precipitation when it goes field to field or section to section in measuring just how much rain has fallen on a particular area? And there's a
Really,
way that they can
right.
access that information.
So really good question. And most of these are derived with a combination of both weather radar, which of course is how we look at severe weather and so forth, but it also looks at how much precipitation is out there at a given time. And that's combined with actual observations. That said, the cardinal rule, even with technology and these are they're pretty good estimates, but it's always best to have if the you want the real thing to get a measurement. That's still a standard. It was a standard 100 years ago. It's still now, but many times that isn't possible. But people have production in different places and so forth. And these estimates do offer something very handy. They come in at the spatial resolution of that from the radar is down to a couple miles. So it's really pretty good. But we've all seen this. We know that even in a couple miles that the neighbor can get rain, we get mist or vice versa. So that happens. It's not very common. All of that said though, those estimates in general are fairly good ballpark numbers to use. Depending on the application that you have, if you needed to know within 500ths of an inch or even a tenth of an inch, I would be a little bit concerned. But you look at the correlation between the estimates and the in an actual infield or a point level value, and it's pretty good. The other thing that those radar estimates give us is an idea of what happens. We only have approximately one or two observing sites per county, for example, in Michigan. Of course, so the question is, well, what happens in between? And if you don't have data, but the radar gives us a really good idea. So the spatial patterns from that radar are revolutionary, and that's something that's even more helpful. But if you're actually looking at an individual field, again, for some types of applications, it's still you might want to be pretty well cautious about that. And the measurement, your own measurement's always the best, but they're pretty good. And there are a number of places you can get these. I can put some here in a moment. I can put a couple of links up that you can get this the estimates, and they're available both from NOAA, from the National Weather Service, and there are many commercial sites that have. They're based on the same data. So
Okay.
it's a pretty good it's good technology. It's improving, but again, I'll stay. I'm a probably an old-fashioned kind of guy, but technology wise, it's still best to have your own observation if you can get that. Sometimes you can't.
So that leads into our our next question. Is there a weather forecast system that shows the error bars around a forecast? Dry forage producers make decisions
Yeah,
based on that 2 to 3 days ahead. Is there a way
right.
for us to see which direction the forecast is more likely to change?
That's a really interesting question. It's a good one.
It's a good
And
question, Leon.
it's I think the answer is nothing that I know of operationally, but the technology is getting close with now with the use of artificial intelligence and learning. There are possibly some new product. The answer to the question, the direct one is are some research projects that did exactly what you're talking about, or looking at a forecast and how much precipitation, the timing of it. One of the real challenges with our forecast guidance is the timing of precipitation and when does it occur. And of course, that does have relevance from what Kim showed about those environmental factors and the first couple stages of drying and being at the mercy, well, it was some mercy anyway, of the weather, and then beyond that, there's a definite role there, but there are limitations. And of course, the farther out you go into the future, the less confidence you have about the outlook. But there are error bars, and I'll be the first to admit because we've looked at this with EnviroWeather a number of times. It's limited, especially as you go out beyond 2 or 3 days into the future. It's tough, and especially with when does precipitation occur, not even how much. You have to worry about that too. But there are technology is starting to get towards though what you're suggesting, and it will be for other applications as well. And I guess I would summarize by saying that I think in the next couple of years that there probably will be maybe commercial products, or there will be certainly products from NOAA that will look at some of these types of questions. That's an individual, pretty specific question, but it's an important one, obviously, if you have forage and are looking at the timing of it. Right now, I don't know of anything offhand, but I don't think it's very far away.
So Jeff, that in our remaining 6 minutes, I've got two things. I'm going to ask Kim if you could queue up your slides in just a second, but I've got one more question for Jeff, and we'll have you finish that last slide, Kim, that I had you wait on. Will the cuts to or from our federal government on places like NOAA affect the ability for that to happen, Jeff? That predictive kind of modeling that you're talking about, is that something that we are going to see in the future?
Yes, and the reality is, and most of you may not be, but many of you are aware that because of the scaling back of the federal government, there are a large number of people with NOAA, which is the parent organization of the National Weather Service, and all the climate information services as well. Basically, there are people leaving, or that will be forced out here over the next or cut out. And there's no question that this is going to have an impact on our weather and climate services. It already has, and it's a scramble for people like, well, me. I'm lucky to be able to use the information from NOAA because it's what we all use. And the base of it's like the food chain in the ocean with the phytoplankton that nobody respects, but they serve as the basis of everything at the bottom. NOAA does the same thing and plays the same role, even more, in that they collect all of the information, the data, the observations, process that, and then run the models. We have to have that. Otherwise, none of this would happen. But even going a step further, and in terms of the delivery of that, the forecasts and what we actually see as finished products, it's going to be very difficult with the reduction in people and just basically an infrastructure for that. I know that they'll give it a valiant try, a gallant effort, but it's going to be difficult. So we will see, unfortunately, probably impacts there, and it's just a reminder again of how important that part is in NOAA, the data collection processing. The everybody, whether they're public, they're commercial, private, we all use the same base information and need to have that if we're going to have be able to say anything about weather and climate. So
Thank,
I'll stop there.
all right. Thank you, Jeff. Kim, I'm going to ask you to go ahead and share your slides again, and you can round us out in the last 3 minutes that we've got. So thank you.
Okay, so I had one slide left here, and it's just about controlling ash in your forage levels. The desirable ash level that we're looking for in hay and haylage should be less than 10 to 11%. That's how much mineral is actually in the forage. If you have a test number that is more than that, it means that some soil got into your forage. Soil is not a nutrient for animals. It is not digestible. It's just taking up space in their gut and not doing anything useful. It also inoculates your forage with things you don't want, like molds and undesirable bacteria that live in soil, like Clostridia, Listeria, Salmonella, and Klebsiella, that can cause spoilage of your forage. So we want to keep that out of there. So sometimes you have sources of soil contamination that you can't control. The only really good one of those that I could think of is if you have a forage field that's next to a gravel road. We have plenty of those in Michigan. In dry conditions, you'll often drive along and you'll see significant coating of dust on the forage that's next to the road. Not much you can do about that. But the other things I've listed here are things that you do have some control over. One is don't harvest when it's muddy. That's going to get more mud on everything. There's a lot of other reasons not to do that. Sometimes we have to, but avoid it if you can. Don't cut too low. If you have your cutter bar set too low and you're occasionally sculpting the ground, that is going to get too much ash into your feed because every time you shave the ground, you're kicking up dirt and it's going into the forage. We also pick up dirt from the surface of the ground due to vacuum from impeller conditioners and also from angled disc mowers. So if you want to reduce that source of ash, you want to use a roller conditioner instead of an impeller, and set your disc angle so that it's more flat in relation to the ground rather than angled. Don't cut too fast. If you're using a disc mower, the faster you cut, that is going to increase that vacuum from the spinning of the blades, and it also can increase bouncing of the cutter bar so that you have a greater risk of scalping the ground. Check your rakes and mergers. Don't get them set too low. You don't want those teeth to be digging into the ground and kicking up soil. And lastly, if you are using a packing tractor in a bunker or a pile, this is a good argument for having some kind of a surface control around that silage, because if you get mud on your pack tractor wheels, that's a really good way to introduce ash into your silage. And that is the end of that material.
Thank you very much, Kim. Appreciate your presentation today. Always love to hear about forages, of course. And Jeff, thank you very much for, I'm going to say, a good forecast. We got a little rain, a little warmth and sunshine coming. And with that, I'm going to say thank you for being our guest today, and we will see you next week.